up to this point, the only types of hypothesis tests we've done have been one-tailed, either left-tailed or right-tailed. But there's a third type of hypothesis test that's a two-tailed test. Dulux Paints conducted a survey and found 42% of males say their favorite color is blue. Haley, a statistics student, surveyed 150 randomly selected college-age males and found 40 said their favorite color is blue. Does this result suggest the proportion of college-age males whose favorite color is blue is different from the Dulux survey? And so, as always, when you're doing these problems, you want to first think about what the variable of interest is. And in this particular problem, it's whether you say blue is your favorite color or not. And so that's a qualitative variable and has two possible outcomes. Either you say, yes, blue is my favorite color, or you say, no, blue is not my favorite color. So that suggests that we would analyze this data using a proportion. Then what you want to do is go ahead and structure your null and alternative hypothesis. And when you do this, the null hypothesis is always a statement of no change, no effect, no difference. In this case, the no difference means there's no difference between college-age males and males in general in terms of the proportion who say blue is their favorite color. And so the statement of no change here is that the proportion is 0.42. Then we decide, what are we trying to gather evidence to show? Here we're trying to show if the results suggest that males in college-age males, feel differently than males in general. And so we're not giving a direction in terms of the alternative, whether more males in college feel this way, a lower proportion. It just says different. And so that suggests the alternative is a not equal to alternative. The second step, which we call the textbook step, is deciding on a level of significance. Periodically, you're going to come across problems where I don't give that to you, and it's up to you to judge what you think an appropriate level of significance would be in order to be able to reject the statement in the null. I'd be perfectly fine with you just going to the old default that the level of significance would be something like 0.05. And that basically means that if the p-value is above 0.05, you will not reject, and if it's below 0.05, you would reject. And now the third step is to actually conduct the hypothesis test. To conduct the hypothesis test, we want to go ahead and use the normal model. And to use the normal model, we had three criteria that had to be satisfied. First, you had to have a random sample or a randomized trial. Here we have a random sample of 150 college-age students, so we're good there. The second is the normality requirement. Remember, the normality requirement was that n times p times 1 minus p has to be at least 10. N is your sample size, the 150 college-age males, and p is the proportion stated in the null hypothesis, because we always assume that that statement is true until we have evidence to the contrary. And so we're going to compute 150 times 0.42 times 1 minus 0.42. And I'm getting about 36.5, which is certainly at least 10. And then the third requirement was the independence requirement, namely that the sample size is no more than 5% of the population size. Now here, we're not giving you the size of the population, but we do know the population that we're studying is all college-age males. I think it's perfectly reasonable to say there's at least 1 million of them. And so if you took 5% of 1 million, it's definitely bigger than your sample size of 150. So I think we're good to go there as well. So this means that we can go ahead and use the normal model. So now what we're going to do here is just jump right to StatCrunch. And we're going to select stat, proportion stats, one sample. In this case, we have summarized data, so with summary. Now, how many of the males in our survey said blue is their favorite color? It was 40. And so we're going to say we had 40 successes out of 150 trials. The proportion stated in the null was 0.42. And then we leave the not equal to alternative here. And then we click compute. We're getting a p-value of 0.001. Now, one other thing that I want to do is explain to you what StatCrunch is actually doing for two-tailed tests to get this p-value. Notice that our sample proportion is about 0.267. You see that?
Yeah.
Now here we said that we can use the normal model. So I'm going to just draw a sampling distribution of p hat where the mean of p hat is 0.42, the proportion stated in the null. Our sample proportion is the 40 out of 150, which StatCrunch computed for us as 0.267, which is right here. Now, 0.267 is 0.153 away from 0.42. In other words, if you will, from here to here is a total of 0.153 units. In a two-tailed hypothesis test, you're going to reject if your sample statistic is too small or too large. And so what StatCrunch is going to do is not only compute the area under the curve to the left of 0.267, but it's also going to compute the area under the curve to the right of 0.573. 0.573 is also 0.153 units away from 0.42. So the p-value in a two-tailed test is the sum of the areas of those two regions.
Oh.
So if we go back to StatCrunch and we select stat, calculators, normal, we put in our mean of 0.42. Our standard deviation we know is 0.42 times 0.58, divide that by 150, and then take the square root, we get the standard error. That's going to be 0.0403. And then remember this between, we can find the area between that 0.267.
I have a real quick question.
Sure.
So we could just use the standard error from the hypothesis test then?
Yes, that's always what you're doing here. So the standard error that I'm using is the square root of P1 minus P over N.
Mm-hmm.
So for this one, that's 0.42, 1 minus 0.42 over the 150. And that's where I got the 0.0403.
Okay. So we implement standard error for standard deviation.
Yes.
Okay.
And then this right bound was 0.573. If I hit compute, see how I get 0.99985, right? That's the area in between. So the area in the tails is going to be 1 minus that value. using the complement rule. And so that's where the 0.0001 comes from. So yeah, if I did the area and tails of the distribution up there is going to be 1 minus that 0.99. It says 985, so that's really 0.9999. I'm getting 0.0001, which is what we got right there.
P-value is all that it's not covering then? Or
Correct. It's the non-shaded region. So this red region that you're seeing here is that value, all this right here, if I was to shade it in blue.
Gotcha.
Right. And so I'm just finding the area and the tails. I didn't have to do it that way. What I could have done if I wanted is said, all right, I'm just going to click standard and find the area to the left of 0.267. And you see how I'm getting 0.00007. And then literally I could just double that because the area to the left of 0.267 is the same as the area to the right of 0.573 because of symmetry. And so then I would also get my p-value of 0.0001, right? Because if I took 0.0007337 and double that, I'm again getting 0.0001. Now, I'm not saying that I'm going to ask you to do this by hand like I did building out the normal model. I just wanted to show you where this p-value from StatCrunch using the one proportion test is coming from. And the fact that with two-tailed hypothesis tests, you have to find the area in both tails of the sampling distribution, because you're going to reject if it's too high or if it's too low. And ahead of time, you don't know whether your sample proportion is going to be above or below the mean. Now, certainly this p-value is low, and because that p-value is low, that's pretty significant evidence against the statement in the null hypothesis. There is sufficient evidence to suggest that the proportion of college-age males who say blue is their favorite color differs from males in general. So in this hypothesis test, we were able to reject the statement in the null and say that college-age males have a different proportion of college-age males say blue is their favorite color versus males in general. One of the things that you can do with two-tailed hypothesis tests is actually conduct a test using a confidence interval rather than going through the formal hypothesis test procedure. So when you're doing the null hypothesis that p equals some value versus p is different from some value, you can construct a 1 minus alpha times 100% confidence interval. If the interval contains the proportion stated in the null hypothesis, you do not reject the null hypothesis. However, if the interval does not contain the proportion stated in the null hypothesis, then you will reject the statement in the null hypothesis at the level of significance alpha. So for this deluxe paint scenario, remember we said the null is that p equals 0.42 versus the alternative p is different from 0.42. Let's use a 95% confidence interval to test this hypothesis. We already went ahead and verified the normality requirement, so all we have to do is construct the interval now. And so you're going to go stat, proportion stats, one sample with summary. We had 40 males say blue is their favorite color, 40 college-age males say blue is their favorite color. out of 150. So 40 successes out of 150 trials. This time you're going to select the confidence interval radio button, and we're doing a 95% confidence interval. Click compute, and here's the results. And so now we could say we are 95% confident the proportion of college-age males who say blue is their favorite color is between 0.196, the lower bound, and 0.337, the upper bound. Notice that the proportion stated in the null, 0.42, is not contained within that interval. Therefore, there is sufficient evidence to suggest the proportion of college-age males who say blue is their favorite color is different from 0.42. The added bonus of constructing a confidence interval is you actually have a range of values for which you're 95% confident that blue is the favorite color of college-age males. You're 95% confident it's between 0.196 and 0.337. So not only does this tell you that the population proportion is different from 0.42, it gives you the added information about the fact that the proportion is likely between 0.196 and 0.337, in other words, below the true population or the proportion we stated in the null.
So it's another way to find out whether you're going to reject or not.
It's another way to find out whether you're going to reject or not, plus it gives you more information than the formal hypothesis test does.